Okay, this demonstration is going to be an example of solving quadratic equations. Now remember that quadratic equations follow this form. ax squared plus bx plus c is equal to some kind of a 0. And the reason we're doing that is because we were trying to find out where this equation crosses the x-axis. Okay, so we're going to probably get two answers from here, and both of those answers are where the parabola crosses the x-axis. Now there's a bunch of different ways of solving this, and there's also a bunch of different situations we can do here, but briefly what we're going to do in this particular example is we're going to solve this particular equation by what's called completing the square. Okay, so let's go look at a problem. Our problem says solve for x if f of x is equal to x squared plus 6x plus 4, and f of x is also equal to 0. So that means if f of x is equal to this and f of x is equal to this, that means that this is equal to that. So I can set up my problem as equal to 0. Now, if I could solve this by factoring, which is the first method, I would. But there are no factors of 4 that add up to 6. So I would do something called completing the square. How do we do that? Well, I'm going to subtract the 4 to this side of the equation, because 0 minus 4 is negative 4. And I'm going to try to search for something to go into here that would complete the square. Okay, what number could I put in here that would make this a perfect square trinomial? Okay, there is a trick to this. What you do is you take half of the linear coefficient and square it. Now remember, the linear coefficient is called b, so we could think of it like this. Half of b squared will be the number I put into here. So half of 6 is 3, 3 squared is 9, and I add that to both sides. Alright. Now that I've got this x squared plus 6x plus 9, I can actually factor that. Again, it's a perfect square trinomial, so I get x plus 3 quantity squared, and on this side I get 5. That's pretty fortunate, because now I can just take the square root of both sides. X plus 3 squared, and then again the square root of 5 on both sides. That's going to make the square disappear, and I'm going to end up with x plus 3 is equal to the square root plus or minus the square root of 5. Now notice I said plus or minus because I'm going to have a plus and a minus answer that would work here. Finally, this gives me x, subtract 3 from both sides, and I get x is negative 3 is equal to negative 3 plus or minus the square root of 5. What does this tell me? Well, I know that the square root of 5, let me just show you real quickly. I know that the square root of 5 is somewhere in between two other perfect squares, the square root of 4 and the square root of 9. I know that the square root of 4 is 2, and I know the square root of 9 is 3. That means that the square root of 5 is somewhere between 2 and 3. Now this is just a little guesstimating thing that I've developed, but the way you do that, the way you guesstimate it pretty exactly, is figuring out what the distance between 4 and 9 is. We know that that's a distance of 5, isn't it? What's the distance between 4 and 5? And that's 1. So the distance between the square root of 5 is about 2 and 1/5 of the way between 2 and 3. 2 and 1/5 is about a 2.2. You can check your calculators on that. If I go back up here and plug that in, I get x is equal to negative 3 plus 2.2, or x is equal to negative 3 minus 2.2. That gives me a negative 0.8 or a negative 5.2. That tells me that my graph of this parabola, 1, 2, 3, 4, 5, 6, I'm just going to do that real quickly, crosses the x-axis at a negative 0.8 and at a negative 5.2. 1, 2, 3, 4, 5. There's the 0.2. And my parabola is going to look probably something like that. It's going to open upward because the a is positive. If you go back to your original equation and you look at the coefficient in front of the x squared, if a is a positive number, that means that my parabola opens upward. If my a is negative, my parabola opens down. And there's your problem. We'll do some more of these later with different examples, but that should help you out a little bit. Good luck.